So today we're going to be looking at a vertical projectile motion question. This is a past paper question that has been converted into a PDF that you can find online by just searching vertical projectile motion questions. I'm now going to convert it into a video version so that you can better understand it. Don't forget to subscribe. Yeah, so we're going to start off with question 5. It's a really big document that I will be going through bit by bit, lesson by lesson. So let's start. So it says a ball A is thrown vertically upward from a height h with a speed of 15 meters per second. At the same instant, a second identical ball B is dropped from the same height as shown in the diagram below. So both balls undergo free fall and eventually hit the ground. So 5.1, an easy question. Explain the term free fall. So an object is under free fall, or it's a free falling object if it is only and solely under the influence of gravity. So if the only force that's acting on the object is gravity, then it is a free falling object. So free fall is a falling object under the influence of gravity. So that's basically free fall. So sometimes they ask you free fall, sometimes they ask you for projectile motion. Definitions are pretty much the same. There really is nothing to it. And then we look at 5.2, which then says we should calculate the time it takes for ball A to return to its starting point. I'm just going to use the space on the side to do that. So the starting point of ball A is right there. So you have the ball A that goes up to maximum height, comes back here. So that's A. I'll call the other side A prime. So the rule is, so what happens is all the time, if you have an object being thrown upwards, as it returns to its starting point, it has a velocity that is equal in magnitude but opposite in direction. So ball A was moving at 15 meters per second upwards, therefore on the other side it's 15 meters per second downwards. Right, so to calculate the time, I'm going to use VF is equals to VI plus A delta T. Keep in mind that I always take down as positive unless there is an exception or I'm specifically told to take a specific direction. So looking at motion A to A prime, I'll then say that my V final is positive 15 whilst my V initial is negative 15 plus 9.8 by delta T, which is what I'm looking for. Therefore, my delta T would be 30 divided by 9.8, which is equals to 3.06 seconds. So that would be your 5.2 there. 3.06 seconds. So it takes 3.06 seconds for the ball to go from A to A prime. So from where it was thrown back to its starting point today. So it would be your 5.2. So just want to highlight the importance of giving the correct direction. So V initial is upward, so it's in the opposite direction of motion. Therefore, it's negative, as you can see there. So that would be your 5.2. And then moving on to 5.3, we want to know the distance between ball A and ball B when ball A is at its maximum height? So this is a very interesting question. It has quite a lot of marks, so it's just falling. So ball B is going that way. That's B. And then A is being thrown upwards. So you want to know the distance between the maximum height of ball A and the distance covered by ball B. We do know that from A to A prime in the previous questions, it took 3.06 seconds to go from point A to A prime. Therefore, as a fact, it then takes us 3.06 divided by 2 is 1.53. So it takes us 1.53 seconds to go from A to maximum height, and another 1.53 seconds to go from maximum height to A prime. So divide by 2 equals 1.53 seconds, like that. So now we have the time. We can yet use this time to calculate displacement of ball B and displacement of ball A separately. I'm just going to use the space here to say in blue, delta y A equals V initial delta t plus half AT squared. My V initial is -15. Very important for you to keep the sign, plus 1.53 plus half 9.8 1.53 squared. I'll just punch that into my calculator. 1.53 plus half 9.8 1.53 squared giving me negative 1.48 meters. It's displacement, it's not distance, therefore displacement does have a direction. The ball is moving upwards in the opposite direction of positive, so it's actually 11.48 meters up. So it's 11.48, and then for ball B, delta y is equals to V initial delta t plus half A delta t squared. My V initial ball B was dropped, so it's 0, 1.53 plus half 9.8 1.53 squared. I'll then just punch that into my calculator. Also giving me a positive distance now of 11.48 meters. Therefore, equals 11.48 plus 11.48 which is 22.96 meters. So that's the distance between the two balls there. So that would be the distance calculated between ball A and ball B.